Testing. What's up? I'm Jacob Blitzo, your Elixir Mentor, and welcome to another exciting episode of the Elixir Mentor Podcast. This is where we discuss everything related to Elixir, from interviews with enthusiasts, pioneers in the community, to innovative projects and libraries shaping Elixir's future. Today, Brian Cardarella, CEO of DockYard, joins us to discuss LiveView Native. This framework allows developers to build native and web applications using Phoenix. Brian, welcome to the show, and thank you so much for joining us. Do you want to just give a brief introduction of who you are?
Yeah, so first of all, thank you, Jacob, for having me. And apologies to those watching on a Tuesday instead of a Friday. I've been wanting to come on for a while. We're waiting to get to the point where we got to the release of LiveView Native, but my Fridays are always booked up. And so Jacob was nice enough to move his regularly scheduled program to accommodate me. So I started DockYard about 12 years, I think it was like 2009, late 2009, early 2010. We were originally in Rails consultancy, started to do a lot of client-side application development in Ember.js. We grew that to probably be the largest Ember.js consultancy in the world. And as Ember started to go out of fashion, actually before that, I think I had read Dave Thomas's book, Programming Elixir, and I went when we had an office. I just went into the office one day and said, "All right, everyone, stop doing Ruby and Rails. We're doing Elixir and Phoenix from now on." And we retrained most of our Rails devs within a week. And that's back when Phoenix had the Rails. Its project structure was more similar to Rails, and so there was a lot less to relearn. And I wouldn't say that they were within a week fully trained like Elixir developers, but they, were effective in writing Phoenix applications within a week. And since then, our big kind of real, I'd say, when people got to know DockYard in the Elixir world is when I was fortunate enough to hire Chris McCord to work on Phoenix full-time. And that happened, I'm going to butcher the years, but maybe 2016 or so. After I read Dave's book, I used to write these annual like retrospectives for DockYard, where I would admittedly divulge way too much like insider knowledge on DockYard. It's like talk about our financials and stuff like that, and probably not an awesome idea. But they were interesting for people. I was doing it because at the time when I was starting my consultancy, that information wasn't out there. So I felt like if I had something to share, I would share it. But I think in one of them, I pretty much said, we are now an Elixir consultancy. And Jose or Chris read this. And then somehow we got connected because Chris had left his prior job and was, in his own words, fun employed. He was, I think, primarily focused on Phoenix trainings at the time. And we had a short phone call. His only concern was whether or not we were going to try to own Phoenix. And I said, whatever it is you want me to sign, that's fine with me. It's your IP. We just want to support the effort. It's in a consultancy's best interests, I believe, to, especially in a space like Elixir, where we do well if the ecosystem continues to grow, and it does well, as long as we position ourselves where we believe that we are a very good competitive software consultancy in the space of Elixir. If Elixir gets bigger, then we benefit from it. And I felt it was best to support Phoenix at the time, and still now, as the predominant Elixir library and framework. That if that effort continued, let's put it the other way, if that effort had stalled, or if Chris ended up at a product company and they wanted him to focus on one part of Phoenix that really wasn't beneficial to everyone else, that hurts DockYard. That hurts everybody. So I felt, at the time, that was probably the best use of money, and definitely worked out. Beyond that, other projects we've done, we tried and failed to get WASM compilation. That was through a project originally called Lumen, then renamed to Firefly. That failed for various reasons, but probably the most obvious in hindsight reason is that DockYard is just not in a position to financially support such an effort, and especially the ongoing requirements there. I do think, however, that a first-class WASM compilation target in Erlang should be pursued. And there's a lot of upside to what we're all trying to do if we get that. If for no other reason than because it's keeping up with the other languages. Like other languages are adding WASM as a compilation target, and we should have it. The Elixir releases was actually we had hired Paul Schoenfelder to build out Distillery. Am I pronouncing that? Distillery 2.0. And a lot of the work and research that Paul had done that was put into that ended up being repurposed for what became Elixir releases. And this was, earlier on in Elixir where we were still struggling with, like, how do you deploy an Elixir application? And let's see, what else are we? Various open source stuff, but we've always been the top sponsor of ElixirConf, starting from the second year, not from the first year. I had, they were going to meet eventually, but I kind of accelerated the meeting of Sean and Jose for the NX project.
Nice.
At the time, Sean had released the genetic algorithms book, and I started to wonder if, distributing machine learning tasks was something that Elixir could get into and become a differentiator there. The kind of eventuality is, we're going to run out of GPU or CPU within a particular machine or even in a closet, and distributing those tasks has benefit. Now, there's the whole aspect of the network topology and, what the latency of sending those tasks over the network means for the overall job run, and perhaps in certain areas not ideal. But I still thought it was worth pursuing in some ways. And so I reached out to Sean. He didn't really know anyone in the Elixir space. And I was like, yeah, talk to Jose. And so I connected them. But I think Jose was already thinking about some of this, and he probably would have met Sean at some point. So let's say I sped it up by a month.
Hey, a month is a month.
I know. We also financially support the NX project. So Paulo, who is on the core team for NX, he works at DockYard, and for the most part, over his tenure here, he's been exclusively attached to NX. But we want to get it to the point where DockYard has an interest there. We want to generate business and start getting machine learning contracts. And so a lot of what's been happening in that space is really, really, the speed of which they're working is ridiculous. And I think of what is going to be coming out over the next 6 months from what I've heard. I don't want to spoil too much. It's not my, it's not my spot to kind of like share what people are working on. But I think it's going to be really, it's going to like, NX has been catching up to what, effectively Python has been at. And I think especially in the world of like distributed stuff, which is my original interest, this is where it's going to start to outpace. Mm-hmm. And so that should be pretty exciting.
Yeah, that's amazing. I'm sure I speak for everyone when thank you for everything you do for the Elixir community. Just bankrolling awesome projects, open sourcing amazing things, and even all your education that you do.
Yeah, DockYard Academy. So that was, I'd say the timing on that wasn't awesome. We had no clue this was going to happen. The whole tech market dropping out. I think we released it, we hired Brooklyn, who kicked ass on it, and he built up a 3-month program. Our goal was to create new Elixir developers. We weren't really targeting senior developers transitioning over. The one of the bigger issues I've seen in the Elixir space is that everyone wants a senior, and because seniors are easily retrained or they know Elixir. I think junior developers need to flourish in this space, and how do you bring them up properly? So Brooklyn figured that out. He put together a great program for that called DockYard Academy. It's all live book. But unfortunately then, the tech market fell out. And so hiring dried up. The ROI on continuing to run cohorts in creating new students for a space where there were significantly less jobs than there were 6 months prior, became something that we had to focus away from. We have all the content done and we want to get back to it. These markets kind of work in waves. So as the demand starts to build again, we'll readdress that. But thankfully, we've been able to, Brooklyn's been helping us out quite a bit on LiveView Native's documentation and live books.
That's
and then,
great.
The last project there, of course, being LiveView Native.
I feel like it's a weird trend that you're seeing right now. Oh, and it's not just the Elixir space where everyone wants senior devs and no one wants to hire any juniors. And like, I understand where they're coming from, but I think it's going to put companies in a real big bind when those senior devs start retiring and they need to replace them.
Well, I mean, there's that. There's also what's coming up with generative code, AI, and are we gonna? I actually just spent yesterday working off of CodeGen from ChatGPT to test it out. It actually works scarily well as long as you set it up properly. You have to tell it not to hallucinate and write code that only works, and it's not too bad. And that's I run a consultancy, but on the opposite side, those juniors that are getting into it, are they going to become overly reliant upon that, where their skill and their upskilling of their own abilities is now not holding pace with what traditional upskilling has been in the industry? And so as those seniors retire and the juniors are not upskilling their own ability as fast, or they're more reliant upon the tool, are we going to see an even greater skill gap?
I
don't know.
I think we already see it in the game development area.
Right.
You have AAA studios releasing garbage, and you go back to the late 90s and you had amazing stuff and they were working on dial-up modems. So I think you're already seeing a major skill gap created.
Roller Coaster Tycoon was written in assembly, in Microsoft Assembly. The entire game.
That's so funny you brought that one up. I used to play that. That's hilarious.
I mean, it kind of shows you, I think on the one hand, the complexity of those games was a lot less. And so, the target they had to hit was not as high as it is now. But I think some of those game developers were incredible software engineers, just unbelievable.
When the multiplayer stuff started, Tribes, it would have been World of Warcraft or StarCraft back then.
I mean, even Doom had LAN and I think direct dial-up multiplayer, but the real one that started to work in a very intelligent fashion was Quake, because I think it was Quake World that really got this down, where network latency became a problem when you had multiple players in the game. And so what they had to start coding in here was knowing your current vector, where you anticipating where you're going to be and drawing to that, right? And so really what you're seeing on the screen is not necessarily what was represented on their machine, in the latency chain of getting from their machine to your machine. It was more of a
predictive movement.
Exactly. Prediction on where they're going to be, that type of stuff. And so, network, multiplayer games are insane when it comes to that.
Yeah, it's insane. I just started reading a book for architecting multiplayer servers. And I have a lot to learn.
I think most of us get into the software development game because we want to become game devs. I think that's pretty much across the board for most software devs. And then, we kind of fall into one bucket or another.
And then we start building ERP solutions for people.
Yeah, I know. Having to parse an Excel spreadsheet.
Yep. That's funny. All right, let's dive into the exciting topic of this conversation. So you just released, I think it was about 2 weeks ago now. LiveView,
just before the conference.
Yeah, LiveView Native. What is it? 0.3.
Yes.
And
so go ahead.
Yeah, go ahead. Tell us what it is.
So, excuse me. 0.3 is now the version that we're recommending that people actually use. We've been holding this back. I think for I'd started the project in March of 2021. And there were like two different things that I was experimenting with that gave me some confidence that this would work. The first was I was wanting to build a Apple TV app, and I was looking into it. I was like, I don't really want to learn Xcode and Swift and all this. And so Apple has this just for Apple TV, this app building kit called TVML. And it lets you build like very rudimentary Apple TV apps using this markup language. It's kind of like XML based. And when I was building that, I was like, oh, I wonder if I can just do this with LiveView. And I could set up a Phoenix server, and then the TVML client looked like it was just running a Safari or WebKit or whatever. WebKit, like Chromeless thing. And then whatever you were rendering. Whatever you were rendering. I'm guessing. I mean, it's all Apple, so it's closed source, right? So I'm just best guessing here. Whatever you're rendering in the viewport would then get rendered as native elements on the screen. But being able to do state updates and responding to events and these type of things, I was like, oh, I could do this as LiveView, and I experimented with it. And because the document was XML, there's enough in LiveView that's very hard coded to HTML, and it would have required a decent amount of work, especially if you're just making like TVML is not a compelling enough destination target to like really put a lot of time into. I was more interested in just spiking it. But this is also COVID time where everyone had a COVID app idea, right? And so my COVID app idea was drive-ins. And I had left DockYard in 2019, but I was still like owner of the company and poking my head in. And I'd left for a couple of reasons. Number one, at the time, I'd always said I only wanted to do it for 10 years or hit a particular revenue number. And we hit both. Like I hit my 10-year mark and revenue number goal in 2019. And we were projecting that. And so I had told my COO at the time in 2016 that I planned on like retiring from DockYard. So there's like almost a 3-year like getting ready for this. And I was also just experiencing burnout, like significant burnout, like building a company on your own, no matter what the size is. I think that there are times that you should just like take a month off to like re-examine stuff or figure out whether or not the way you're running it is correct. And so because I started the company on my own, on my couch, my first go around at it, I was so used to doing everything myself, like, wearing all the hats. And if something wasn't happening the way I felt like it should be, I was like, okay, I'll just do your job. And that's not sustainable. Add on to the top of that, like having to write code for things. And my real interest is just going out and racing sailboats anyway. So like, that's what I'm focused on for half the year.
I used to live in Milwaukee on Lake Michigan, and every Friday I would sail race boats, and that was so much fun. I miss it.
What boat?
Oh, it was like it was like an RV class. I'm trying to think what it was. It was a 33-foot like Catalina or something.
Okay. Yeah. I mean, was it handicap racing? You're going a bunch of different boats, or?
Yeah, it was handicap. Yeah.
Did they have any ice boat
just
racing?
Like a social. It was like a social event,
Well, that's the way sailing is. Sailing's a lifestyle, and it's so much fun. Just it's different than tech, and it's kind of like a way for me to detach from this quite a bit. Even though I have now loaded my boat up with so much tech, and I'm trying to do like something with Elixir and sailing. But anyway, it's good to like get out of the house and get on the water. Anyway, all that to say, like my interests were kind of moving away from DockYard, mostly in hindsight because I was probably burnt out for the last like 4 years of being there, and I just
burnout is a real thing.
It is.
I moved into an RV and moved into the like Teton Mountains because I didn't want to code anymore, and I did that for like a year without touching a computer.
Well, I mean, for me, I've always been able to muscle through it, and I'm not suggesting that the way it is for everyone, but also at the time I could do that. I was also in my 20s. I wasn't married. I didn't have a kid. I didn't have a house. I didn't have all this other stuff. And, I got married in 2011. sorry, 2012. I should get that correct. We got a house. We had our first son in 2015, and then we bought our first house later in 2015. It was going to be like require a ton of work, and so all these like actual life things were happening that I didn't have in the past. And then getting older too, has an effect. So there's all these things that I think most software developers go through this, or most people in life. It's like, okay, at some point you got to get your stuff together, and the way that you're living your life one day can't be the way that doesn't happen forever.
I think the problem is when you're young and in your 20s, you grind on that screen from the moment you wake up to the moment you go to bed. And then you realize how unhealthy you slowly get, and you start hating everything because you're not doing anything fun except for building your project.
Well, the worst part of it too is that it validates that lifestyle because it works, right? Mm-hmm. Like grinding it out and putting in the work does work. It gets you ahead. And for some people, so I mean, there's a lot of like talk with like, especially in tech, about equity and stuff. I can tell you that not all software developers are built the same. And I've been fortunate enough to work with incredibly skilled people, like scarily skilled people over the years. I'm a fairly competent software engineer, but I mean, when you talk about people like Jose on that level, it's a different world where they just, I think first and foremost, like the primary skill set they have is just that they can have recall on like where, like knowing exactly what function to use. Like they got a language server in their head, right? Basically. Mm-hmm. And I mean, Jose has the benefit of having written all this, but I can tell you, if I had written all this, there's no way I would remember all of it. And
I have a recall of a goldfish.
Yeah, no, same here. I constantly have to look stuff up. And the most impressive person I've ever seen with this was he worked at DockYard, and he was on the Ember.js core team, Robert Jackson. The guy is unbelievable. He will, like, you can ask him about a particular like function, and he can tell you like the file and line number that it's in, where it's defined.
That's wild.
This came about, as he tells it, from like a car accident where in high school he got thrown from a car, hit his head. And after that, it's just like, I can remember everything. And so I think that, you have to understand that there are developers out there that just have this amazing ability to recall, but even remembering everything, you have to have some level of creativity. You have to have the problem solving skills. And there are some people that are really like at the intersection of all that. And so that's not me. Like, I think I'm pretty good on the creativity and the problem solving skills, but my recall is just absolutely horrible.
Yeah.
Which is why I complain so much about the language server in Elixir.
Well, I feel like I'm about the same. Like I'm competent enough to build anything I put my mind to. Like I can problem solve, figure it out, but I'm not creating a new language anytime soon or like architecting any crazy framework. I mean, maybe with a team of people, but not on my own.
Where were we going before this? We were talking about LiveView Native, right?
LiveView Native.
Yeah.
Circle back.
Yeah, we'll bring it back. All right. So the other thing was that, I was mentioning the drive-in application. During COVID, I love going to the movies, and movie theaters were hurting. And so we had looked into this building. Like I was going to hire DockYard to do this. And actually we had started it. So like with drive-ins, in part why they are not as popular as they used to be, because they no longer are licensed to show what are called first run films. Meaning like when a film gets released in movie theaters, all those theaters are licensed to show a first run film. And that's where everyone goes because that's where the film is. But because drive-ins are like, okay, I can just like sit out here with an AM radio, and watch it for free and, listen to it for free. That's, they want to just force everyone to a situation where they have to pay for it. Understandable. They just dumped $100 million into this production. So the idea was, can we do a drive-in, which is going to be, so like social distance because you're in your car, but do it in a way where we can encode the audio format and still have it perfectly synced up with the video stream. And we had done this with Phoenix. Chris was at DockYard at the time, and so I actually tasked him and a few others with this. We were playing video back through VLC and broadcasting like the timestamps, and through Phoenix Presence, it would, actually synchronize the audio streams in a iOS application. And we were going to do it through CarPlay. So you pull in, it would geofence you to that location, and it would like you pay for the movie, and then you get the encoded high fidelity audio stream perfectly synced back in your car as you're
How
watching
did you
the
sync
movie.
it with Presence?
You'd have to ask Chris. I'm pretty sure he used Presence. Like, it was some sort of telemetry that was being broadcast from VLC would figure out the network latency, and then it would hand off. It would figure out the network latency from you to the iOS client and from the VLC server to the server, and it would negotiate like the timestamp offset that the client would get back the audio stream for. And I think I'm giving a very like rudimentary explanation. But we never released that because I went around saying, okay, now we need to find like some, we don't take like any outside money, but for this, I was like, all right, I'll find like someone that can fund this. And I mean, maybe rightly so in retrospect, but all the VCs were like, yeah, we're not doing any COVID investments. And so that moment passed. But all that to say, we had hired a Swift UI developer to build the iOS and the CarPlay application. And that was my first taste of like really looking at Swift UI. And he's a former DockYarder. He had actually written Phoenix Gen Auth, and I apologize, I'm just blanking on the name at the moment. But I think he's the one that brought up and said, oh, this is composable. Maybe we could do something with LiveView. And so like these two things, the TVML application and Swift UI's composability really incentivized me to try this out. So I had not written any Swift before, and I took the LiveView test suite, and I rewrote all the tests, like the unit tests on the Elixir side, and then the JS unit tests. I rewrote them in Swift, and then I wrote an implementation of the connection protocol. Like we had Phoenix channels because Daniel Reese is maintaining that for Swift, but we used that. And I rewrote like the LiveView programming model, morphed DOM, and most of what LiveView needed to do in a very terrible like Swift implementation. Like it was like functional code written in Swift. I wasn't taking advantage of any of the like nothing that Swift actually wants you to be doing.
Right.
But it compiled and it built a view tree and it could inject it in, and it was fast. And so that's what I had presented. And we had, after I proved that out, this was probably like May. It took me about like a month or two to kind of get to that prototype stage. So this is maybe May of 2021. I'm going to be butchering my years a bit, but we had hired Anil Cord, who was, he was a university student at the time, but he had this good intersection of iOS development and Elixir knowledge. Finding this was really hard, finding the right people to hire for this, because there is like finding people in a particular technology ecosystem isn't that difficult compared to finding someone that has like the cross-disciplinary knowledge on things and deep enough to actually know like how to do things correctly. And so what we started with Anil was really almost a year-long exploration of what LiveView Native even could be. And we went down so many different just dead ends and wrong paths where it was like, okay, we had this whole entire two-way binding system at one point where you could bind to state variables in the native application. And as those state variables updated, it would like send the state information back to the server, and we could do it like other way too. So like when a particular part of state that was bound to a state object or a state variable in the client, if that state updated on the server, it would automatically update the state in the client. And I saw the reason for doing that is because now you're effectively like running all the state-based stuff locally, and it keeps the application mostly performant. You're not really absorbing much server-side rendering at that point. But it really broke the LiveView programming model. Like we were having to build separate applications. Like you would have your regular HTML LiveView apps, and then on a completely separate routes, like just a different way to build LiveView native apps that were like very divergent in the API and very divergent.
So were you just hitting endpoints and just connecting through channels essentially? But
it was still
you
a
had your
LiveView
separate front end.
Yeah, it was still a LiveView. It's just like the way that we were.
Okay.
we had like really messed with how state was like updated, and what happens when the send update function was being called, I think is what we were effectively hijacking at that point. We wrote our own, and it would not always send like what LiveView sends, which are like the diffs and the updates on that. So anyway, this isn't where I wanted it to be. But we felt like we were close to something, and I was willing to kind of let this play out a little bit longer. Went to ElixirConf, the final one that was in Denver, and I think I'd said something really dumb on stage, which is like, "Oh, we'll be done in 6 months," and the worst thing to say on an experimental software project.
Yeah,
because it actually at the time it felt like we were that close.
Yeah.
But what really started to come out after that was we started to really expand it to encapsulate all the modifiers in SwiftUI, which is how you style applications. And our whole kind of approach was quickly breaking down. And, it's not lost on me, the fatigue that sets in when you say something's nearly ready and it takes forever to come out. But I also knew what would have been worse was releasing something that was not ready. And, it would have looked bad for Elixir because, DockYard's name in the Elixir space being attached to a project such as this, I feel like would give it some attention. And then people would try it and say, oh, this doesn't work, or this is junk. And they would have been correct. And so I wanted to let it bake a lot longer. And we almost got to that point again for the following ElixirConf. But when we had built out a chat application, and I don't know why we didn't test this beforehand. We had scaled it up to, I don't know, maybe 23 messages in the chat room at the time, and the performance was fine. But then we released the chat application for ElixirConf. People start playing with it, and we got like 200 or 300 messages in that room. And right away, we're like, oh, this is like dog shit performance, because what was happening was we were parsing out the modifiers that were encoded on each element at runtime, and then instantiating those modifiers at runtime and applying them. So there's just too much cost there for rendering things out. And even with a compiled language such as SwiftUI, it just wasn't performant enough.
Yeah.
And so this prompted me again to kind of hit the brakes and not recommend. Like, we were going to do a 0.2 release, and I was like, we had all of this content ready for like LiveView Native. And I think a few companies started using it. I believe that Teller was using it at the time, or at least playing with it. I don't know if an app ever came out with it. But I mean, when I was putting together my presentation, I also at the time when I came back to DockYard, I was trying to do like hands-off approach to running the company, where I would kind of set direction and try to manage the direction of it, as opposed to getting in the weeds of actually writing the code, because that's what burnt me out last time. And so this created some like disconnects, where I would set like almost too high-level abstract goals for the team. And I'm sure at times they're like, what the hell is he talking about? And because I didn't have like the in the weeds knowledge of the actual implementation cost or some of the blockers that were in there. And this, after that ElixirConf, I really started to think I needed to change that whole approach. Like, if I was out there selling it, I needed to own it, I needed to run it, I needed to be building it. And that way I knew it was going to be built the way to the standards that I had set. So at the same time, we had actually been struggling with something that we didn't have a good workaround for, which was that in the live views themselves were just becoming like a monster, in the sense that we would have separate templates, not just for all the, like for SwiftUI or Jetpack, but for each device. And so like currently in the live view, it's nice. It's nice for some people because you have that tight coupling of the template, and then all the event handling and state management in one place. I happen to prefer isolation, but regardless, when we were now implementing like 10, 12 different templates in a live view, it just got to be gigantic. And it just wasn't like something that I felt like was scalable properly.
And at that point, would you just need a bunch of different render functions and pattern match for screen size and device, or what were you doing?
Yeah, we were injecting platform information into the assigns object.
Okay.
And so you would pattern match on the function signature. It was like format equals SwiftUI or something like And then you can write your platform specific render function.
And then you probably have a lot of reused code as well.
Well, yeah, but not only that, but you end up with a lot of name collision. So if you wanted to have like one thing we ended up doing, I'll get into this on the component side. You can't use table anymore. You can't use form. Like all those things are dedicated to HTML.
Yeah.
And so the right path to take, and Jose, pushed us in this direction, was module isolation. And but LiveView is just completely hard coded for HTML, like through and through. And what I ended up doing was, let me back up. Jose introduced a PR to LiveView that allows you to pass an override for rendering in the on-mount callbacks. And so it's just called render with, and you can pass it a function signature. And I was like, that's great. I can now pass it like a module.render one. And when it renders the template, or attempts to render a template, it will call it off of that render function instead of the local one. And that opened up a whole new world of possibilities for us, where we were now able to like really leverage what I felt like was the right direction overall, which was treating the inbound requests as a format like a encoding type request. So now when you connect with a LiveView Native client, it attempts like with a encoding type of text/SwiftUI or text/Jetpack. We actually do this in a different fashion. Like we do put that encoding request on there, but we do this in a different fashion. There's actually in the I forget which plug it is. Maybe just be the format plug. But there's a legacy API that's now like it's in there. And it's when Chris was testing out coding formats, and he just got sick of having to like override the headers. So if you put on any request to a Phoenix application, if you put question, like a query parameter _format equals, and then the MIME type name, it'll force the request to be thought of as that encoding type. And so we use that in LiveView Native, where we force the encoding type to be for the platform. And then this kicks off a whole bunch of things internally, where when you use LiveView Native in a LiveView, it will put that on-mount callback up top, and it does a content negotiation. So it'll determine what the content type originally requested of the dead render was, and it will like look at the LiveView Native plugin and then deterministically delegate your render function to a format specific render function now. And this was like the architecture that I felt like was the one that now we can start to roll with. In addition to that, in the past year, we introduced this whole concept of style sheets. And if this is starting to sound like a web browser, that's because it effectively is how we start to think about the clients. So one misconception about LiveView Native is that people see it, they're like, oh, that's just a web view. Probably because of Turbo Native, and people know LiveView as being, a web technology. And so we're trying to educate people. It's not a web view, but it makes it a little bit more difficult when I am saying that the clients are browsers. And my talk at ElixirConf went into this, where like the concept of the browser, if you look at some of the pieces of what the browser is rendering, HTML for the template, for the markup, a CSS for the styling, and then its runtime language is JavaScript, and its view tree is the DOM. These are things that we can now swap out, right? So as long as the client behaves like a browser and how it's fetching data, how it's like storing cookies, and it's doing all those connection stuff, then we can swap out HTML for SwiftUI markup. We can swap out CSS for our style sheet implementation. We can swap out the DOM for whatever the native view tree is, and we can swap out JavaScript as a runtime language for, in this case, Swift or Kotlin on the Jetpack client.
Do you just create like DSLs then, essentially, for like copying the syntax of like Swift UI, or how do you handle that?
No. So you don't actually run any Swift UI code. So you don't run any Swift code on the server. The Google Play Store seems to be a little bit more loosey-goosey with this, but our initial target has always been Apple. If we can play well in that space, it feels like, okay, we're going to be able to do it anywhere.
Yeah, for sure.
And so they have a strict rule against no remote code execution. And so what we end up doing is that the markup itself is intended to have feature parity or API parity with views that exist in SwiftUI. So we effectively just have a dictionary in the SwiftUI client that every single view itself is a key value stored as a key value. So the key in that case is going to be the tag name that we pull out of the element when we parse the markup. If you have a text like element, like capital T text, then it just knows to go instantiate the text struct in SwiftUI. And so we're not like, if that, in other words, if we do not have a view represented in our dictionary or in our registry, then you can't use it. And so if you want to extend, like in Swift, the SwiftUI client just starts and stops at whatever SwiftUI's API is. So we don't do things like camera access. We don't do things like map kit. We don't do things like charts inside the SwiftUI client. If you want that functionality, we have add-ons. So we have an extensibility system for it as well. And right now we have a map kit add-on. We have a Swift charts add-on. We have a reality kit add-on as well. That's not released yet. And so you can build augmented reality applications with LiveView Native, which sounds like BS, but it's true. And then camera access is there in AV Kit, but our current version of LiveView Native on SwiftUI client lacks LiveView uploads and streaming. That's already fixed in another library called LiveView Native Core, and that will hopefully get rolled into LiveView Native SwiftUI client 0.4. That requires us to swap out the Phoenix Channels client that we didn't write. And so let me back this up a bit. LiveView Native Core. So there's a lot of stuff happening here. This is why like this project's taking so long, because it's really like 10 different projects under one umbrella. Like LiveView Native Core is everything that you need to write a LiveView Native client up until the point of whatever is specific to that given UI framework. And like our goal is to, at least through DockYard, fund the development of a SwiftUI client, a Jetpack client for Android, for all Android devices, and then a Windows one. But I want to keep it open. I want to open the door to other people as well. There was someone that early on, I think for the 0.1 cycle, they had built a Flutter client, and I've been vocal. I don't want to build a Flutter client because that's not my goal, but I can see why companies want Flutter. And so we should make it easy for people to create a LiveView Native client. And if we're requiring them to re-implement like the channels connection, like their own LiveView model implementation, and handling all the stuff that LiveView does in the client, that's a ton of work. And so I think after somewhere in the 0.1 cycle, I had decided that we were going to extract that stuff out into a library called LiveView Native Core. And that's a Rust library that has Unify bindings. And so that we can compile it and run it on the devices as a dependency of the client, and basically do all of the LiveView stuff, and then just pass, types over to the client at that point. So we'll do all the markup parsing. It'll do like the WebSocket connection, all the dead render stuff. Anyway, all that to say, replacing the channels client in the middle of, we finished, or Sebastian finished the uploads, LiveView upload support and the streaming support while we were in release candidate for 0.3. It didn't seem like it was a good idea to swap out the network layer at that point in release candidate for something that hadn't been like tried out yet. So we actually could probably experiment with bringing it in now that we're released, but I want to make sure that we're rock solid. Like I really dislike, there's a lot of projects that I've been downstream of where you have to absorb like API changes constantly, or like updating to a new version ends up being worse.
Yeah.
And I try very hard not to do this, which is why I've held back LiveView Native for so long. And so we're going to be very careful about how we do the releases.
Yeah. When did we start talking about having you on as a guest? It was a while.
I mean, it might have been. So, I mean, my problem too is that I've reached, like, when I thought we were close, it's like, okay, now I have to like go over to marketing mode. I'm going to start reaching out to people and see if I can come on. And so I have a lot of like broken promises out there. I mean, the worst one was probably the Thinking Elixir podcast, where they wanted me to have me on after 0.2, I think, because I was saying like up until I was like it's ready, and then I realized it's not ready, and I just went dark on them. I don't like not responding, but I think I don't know, I was depressed. I just didn't want to, just put my head in the sand type of moment.
I think developers though, they get it though. When you fall behind on a project, like it unfortunately happens way too often, especially such a large scale.
I get it, and I appreciate that the community has been pretty patient with this. But on the other hand, I also am the one that like went out and promoted it. Right. And so I own that aspect of it. But I'm glad that we did not release it before it was ready, because I think that would have just been a nightmare. I think it would have been bad, because like we're like Elixir also, from those outside the Elixir community, I feel like something that Elixir has going for it is that all these big projects that are pretty public facing, they have a pretty good reputation in the space, and something that could be as big as LiveView Native, I think that I owe it to the community to make sure it's rock solid so that it doesn't like give a black eye to Elixir. Yeah. And that was another big motivation for waiting until it was ready.
I think that's a smart choice for sure. Did you want to do some code run throughs or?
Yeah. So I think what we'll show is I'm going to just build a basic application. And we can even go out and just like try to find some Swift UI like examples and bring them in and just recode them in LiveView Native. We'll try to find simple ones, because like something that's like 100 lines long will be kind of boring to watch do live. But what I'm going to show off is a couple things. So the one of the more annoying parts about native application development are the tools that exist in that space. And Android through like the Android Studio is better, but Xcode has like a reputation that it's well earned. And in terms of when it works, it's great, but the compilation times are really, really slow. And especially coming from a dynamically typed language like Elixir, as Elixir progresses over to typed language, but moving to a strong type language like Swift can be a bit of a culture shock for many people. So anyway, building a new application and then sitting here for 5 minutes while it compiles and then resolving errors is not interesting. What we also found is that giving workshops and teaching people, it's also by far like the worst part of running the workshops is making sure everyone's up to speed. Because if one person forgets to like download the right simulator on conference Wi-Fi or whatever Wi-Fi you happen to be on, you're now asking someone to download like a 4 gigabyte install.
Oh, dude! And what is it? Command line tools, any Xcode
all
update,
that stuff.
Any Xcode update is going to take you hours sometimes, especially on crappy Wi-Fi.
Yeah. So this was not ideal. We benefit from being like behind in terms of release on all this stuff by years, like compared to React Native. And they kind of solve this problem. They have this, I don't know if it's a company or if it's just like an open source product called Expo. And they have they allow you to like compile React Native without having to go through the whatever your compilation environment is. So Xcode or Android Studio or whatever you're doing. And whereas what we're doing is server-side render stuff to a degree. I should actually expand upon that for a minute. Like we do not believe you should be doing everything server-side rendered, just like how Chris says LiveView should not be 100% server-side rendered. There are certain things that make no sense to do, like waiting for the server to update. For example, drag and drop. Like we should not be doing like a dragging event where
a ton of server calls for sorting like, something on your phone,
like wherever your pointer's moving to, it's like giving the XY coordinates and then you redraw that, where it is. No, like dragging should be a client-side event. And just like what LiveView does, it will like notify the server when you drop it. But before that, it's all like client-side stuff. I mean, a lot of visualizations should be client-side.
Well, and you have a lot of power in this thing, You
do. Exactly. Yeah. I mean, you should be using it. And so we do the same thing for our Apple Vision Pro apps. where we had one. Sorry, I had the punishment of going to a conference where I think I got sick from the plane ride back. So
that always happens.
I know I have something developing right now. And it hit me hard this morning. I was like, oh no, I have to go talk for like 2 hours.
Dude, that's what happened with me with the Lisbon conference. I woke up sick and had to cancel my entire trip to Lisbon.
Oh my God.
The morning of, it sucked.
My ElixirConf EU trip was less than 24 hours. I had a commitment back here, and I committed to the conference already. So I flew in, I got like 3 hours of sleep, showed up, gave my talk, and headed right to the airport. And just got out of there. I wish I had hung out longer. It looked nice. Anyway, so all this to say, we kind of looked at what they were doing, and Carson put together this application called LVN Go. And it's a precompiled LiveView Native client, but we can point it at any URL, and we can actually render LiveView Native applications in them. It's great for development. We did run into a few issues during the workshop that we ran at ElixirConf. The first of which was everybody's machine and all their phones run different subnets, and so that was one problem. But there's also, this is where you're kind of playing in the Apple ecosystem, and if it's not important to Apple, it's not going to get fixed. There's some sort of weird bug where, so in LiveView Native, we will watch the internet state. I guess like Swift applications, they can report whether or not the network is connected.
Okay,
and
right. Yep.
If the network's disconnected, we show a client-side view in that case. And so, we want to have a graceful way. We don't want the application to just bomb out. In fact, we have a standing requirement that the runtime of LiveView Native should never crash. In the same way that a web browser never crashes or very infrequently crashes. If LiveView Native encounters something it doesn't understand, it ignores and moves on. And so we never ever crash as much as we can. If you do encounter a crash, report the bug, because that's a critical bug we need to fix immediately. But in the event of network connection, we want to show a graceful message, it shows a offline page or offline view in that case. But what was weird was that we brought in a router so we could set up a local Wi-Fi network in the room for all the students, and we did not have internet uplink on it. And because, despite the fact being on a local area network, but because the internet was not accessible, I don't know how the phone's checking if internet's available. It must be pinging some server to see if it can get there. It put the phone into offline mode state. And so even with the LiveView, despite the fact you were connected to a local server, it would still render our offline view. And so someone thankfully found a way to trick it, where if you first moved over to a Wi-Fi that was on internet, and then you swap back, the phone just gets into a weird state. And this is Microsoft had actually reported this as a bug a year and a half ago, and it's never gotten fixed. And so we need to come up with a little more graceful fix there. Anyway, all that to say, today I'll be working off of my local machine, so it's all going to be fine. But let me get this going here. So
I'll make you full screen.
Okay. So let me just
hide all the classified information.
Yeah, I want to get to a directory where I don't have a billion things in it. I'll just create one called Elixir Mentor. All right. You don't see my screen yet.
No, not yet.
Yeah, I know. I just want to get over there first. All right, PA mix phx.new. I'll call it demo. No, ecto.
And then as long as just describe kind of what you're doing, because I put this as a podcast format tomorrow. So.
Yeah. I just have to install Phoenix real quick. Okay, so try this. Okay, so what I'm doing lowercase. What I'm doing right now, I'm just generating a new Phoenix application. But once I have that Phoenix application generated, I'll share my screen and show you the important parts for LiveView Native.
Yeah, I'm excited. I'm actually excited to play around. I'm gonna have to make an iOS app now just to give it a run.
All right, let me see here. I'm gonna try switching my OBS to include my desktop. Okay, I
Okay,
see
there we
mirrors.
go.
Yes, mirrors. Lots of actually. Me minimize this so you don't see the mirrors. Minimize this. Okay, so
Maybe make that a little bigger if we're going to stay in the terminal.
no, we're going to Zed.
Okay, cool. Do you like Zed? I've been thinking about giving it a
Uh,
run.
so I like trying new things. And I was running into a lot of performance issues with VS Code, like horrible performance issues. And it kind of went the way of enterprise software. It's like, yeah, we got to meet all these needs, and just they don't care about the bloat.
Yeah.
And there were some plugins that just, I forget which one it was. There was one that was just like hammering my CPU. And so I tried Zed after it came out. I was like, oh, well, this is way faster. But understandably, it wasn't nearly as mature.
Mm-hmm.
What I've been running to recently is the language servers. Just they're worse under Zed than they are VS Code. And I don't think
I feel
any
like
of the
my
language
language
servers,
server is always crashes on VS Code. I don't know why.
well, I think that's just the nature. Like the language server stuff has been a really difficult project. It's great that they're now consolidating, and hopefully that's a positive effort.
Yeah, I think it'll be great.
But the to my knowledge, none of the 3 language server authors are using Zed, and so it was just. I think, despite the fact that there's a protocol for it, like there's probably deviations from editor to editor that have to be accounted for, which isn't awesome.
Sure.
I think that like they should stick to the protocol. But I did not like that Zed just announced like that deal with Anthropic. It was Anthropic.
Yeah, Claude or
stuff.
whatever. Yeah.
Yeah, and I turned it off. I think I turned it off, or maybe it's opt-in. But I mean, I'm debating going back to NeoVim and just like Tmux NeoVim.
I don't know. The original. I've always been tempted to try NeoVim, but I don't know if my brain can function.
It's fine. I mean, I think that if you go through Vim Tutor a few times and just like get down everything, and
like I prefer using like Vim Editor when I'm writing like scripts and stuff, but just like, you know, the terminal version. I don't know. I guess I'm always tempted to try it, but I'm like, should I waste my time doing this?
Okay, so I'm just going to add LiveView Native here. I'll kind of step through a couple things. I'll show like if like someone happens to install not everything.
Can you magnify a little bit?
Oh yeah. Let me bump this up here. How's that?
Yeah, perfect. That's great.
All right. I'll close my view tree, my file tree, because it's apparently keeping your file tree open is not viewed highly for some reason. I don't know why.
Dude, people complain. I do it all the time on all my videos because I forget, but it annoys me to reopen it.
I mean, Command B, I have that bound here, so it's
nice,
pretty easy. Anyway, so we'll just do mix steps.get here.
But yeah, people always complain if I do any coding tutorials and leave the directory tree open.
Yeah, I don't know why. I mean, you're losing some horizontal space, and then those are the same people that say you shouldn't go over 80 characters. So, I mean, I got like 200 characters of horizontal space right now, maybe more. Anyway, so I'll just run mix LVN setup. And what this is going to do is kind of step me through the process of getting LiveView Native compiled and set up on your application, on your Phoenix app. So it's right away going to tell me that I'm missing some dependencies, or like they're not requirements, but you should have them. So I'm going to add these in, and it doesn't have an opinion on a client. These are just kind of like the ones that you should have, just because make your life easier. Live form. One of these is actually 0.1 now, and I forget which one it is, but I'll add the client too.
Now, when I'm assuming you build everything in your Phoenix project, right? And then are you exporting and creating the Xcode project, or how does that work?
I'll show you.
Maybe I'm jumping the gun. Yeah.
Yeah. So now that we have all these dependencies, you're going to run mix LVN setup. So actually, if you go back here, it should have told you. Yeah. So it gives you like the next steps here. So mix LVN setup.config, and what this is going to do is it's actually going to code gen into your application. in several places. It's going to set up. So it's going to step you through it as well. It'll show you like we want to write to config.exs. If you want to see what it's going to write, you can show the diff for that. This diff work is not mine. This is, I forget the author, but there's a great library out there. I think it's just called text diff, and it does the work for me. So I can just hit yes on that. I can see the differences that are being put into dev.exs. And so it's properly like the live reload patterns, like the list stopped here. So it's properly doing this. I actually have to, we'll go in and change this because this 03 has a bug. This should be .star, not star dot. So we'll change that manually. I'll say yes to this. The endpoint, it's going to load in our own live reloader. So LiveView Native in dev mode supports live reload, which is like right away when I show people who do SwiftUI development, they're like, holy crap, because you don't have to recompile anything. As long as you're not changing anything in Xcode, like you update your application and it like boom, instantly different there.
I just created a website hosting project in Phoenix where I have different websites within a Phoenix project, and I dynamically route through plug. And I have to go through and set up the live reload because it annoys the crap out of me that I have to like restart and build my server every time.
Yeah, I mean, we I don't think we're using live reload for Beacon, which is another R&D project I forgot to mention. But we have a way to force page updates, I believe.
Nice.
But that'd be a talk for Leandro knows that.
Yeah.
Okay, so finally the router stuff. And now it's going to say, don't forget to run mix LVN instead of gen. So separate projects, separate setup steps. The reason for that is because of what we put into, actually, I'll just open it up here. We'll see up here. Where is it? Console. Right here. So the plugins for LiveView Native. We need these plugins predefined in our config before we can run the generators. I tried to find a way to get like from within Mix to actually force a recompilation at runtime. I think that there probably is like a way to do it, but it was just a lot cleaner just to run them as separate tasks. So if I can ever figure that out, then everything will just be mix lvn.setup, and it'll do all the stuff like in one shot as opposed to the separate steps. Okay. Anyway, so we're going to run mix lvn setup gen now. This will run all the necessary generators. So you were asking about the native project. So when you run mix lvn setup gen, it actually will discover what other LiveView Native dependencies are installed, and it will run their generators for you. As well, it will do the same thing for config. So it will go through and figure out that there's these other like SwiftUI client or Jetpack client or style sheets, and it will run their configs, and it will consolidate the actual code gen graph. I will flatten it down and consolidate it so it's one pass on actually injecting into your files. That's
awesome. So do you have to generate it every time you update like SwiftUI renders?
No. You will have to probably regen if we make changes to certain things. So like there's other files that get installed on your system. There's this native file that's kind of like our version of the web module.
Okay.
And this is what you're going to be using to basically, you can use the LiveView Native modules directly, but this sets up a bunch of other stuff for you. So it's going to do all the routes, all the verified routing stuff. It's going to import the components. So we have platform specific components as well.
Okay, cool.
But in addition to that, we run Xcode Gen, which generates an Xcode project for you. So that's now in the native /SwiftUI directory. And you could open up this native demo SwiftUI demo.xcode project here. And, this will now start downloading all the dependencies for LiveView Native and getting all that stuff set up. So if we're lucky, it's going to show 03 for SwiftUI here and then 03 for Liveform. But this has always been kind of, okay, we're good.
Awesome.
Like dependency management in Xcode is not a solved problem. And it's because I think that they violate like Semver in certain places. And their rules are either too strict or not strict enough. I forget which, but during release candidates, we ran into the most problems. because it was not properly parsing that like release candidate like section of the version string, or it was doing something weird. I forget, but it was just difficult. So anyway, you'll get this project here, and the one that you like people care most about is the content view. In a SwiftUI project, content view is kind of like the main function. It's where the application gets rendered, and our live view here is a macro, and it's just another SwiftUI view. And so these are like callback states, and so it's really weird, like SwiftUI, I think it's Swift, where the callbacks are named arguments with the exception of the first one. And so like we have disconnected : here, reconnecting here. Like, why don't we have connecting like this?
Oh, I forgot that. And that's how it's like.
Like it's just a design decision for the language, and it's really annoying that you can't have a named argument for that first callback. That first closure. And so anyway, but these are the states, and so you connect to your URLs for development and production. Here's the list of add-ons that you can add to your application, and then there are disconnected, reconnecting views, and then the error view, and these are all represented by different views in here. So these are things that would be happening outside of the network connection that if you wanted to go in and customize for your given application, you can go and do. But it's going to require knowledge on how to write SwiftUI applications. And that's like where we differ from other native like frameworks, like a React Native. We are not pushing this idea of build it once, run it everywhere. Our approach here is that we are representing the first class UI framework from the server. And our take on this is that leads to a better user experience. A little bit more work in some ways, but I think that you more than make up for that by having a single place to manage the state, because that's where you put up most of your work at the end of the day, building applications. But you're going to have to know how to style things properly in SwiftUI. You're going to have to know how to style things properly in Jetpack. And it's like, in some ways, learning HTML and CSS over again. But this opens the door for us to not like really have to do like majority of the work.
I'll tell you right now, though, SwiftUI is much better approach than storyboards.
Oh yeah, no, I agree. I mean, honestly, like at one point when we were doing this, I was like, is it even worth it? Like SwiftUI is kind of easy. But then when I tried to actually do like an API application and doing all the state management, I was like, okay, yeah, this is why we're doing this. It's not because like the views themselves are difficult to write now. It's because the totality of building a native application is still a huge pain in the ass.
Oh yeah, for sure.
Okay, so anyway, we're not going to run this because it's going to take forever to compile. So I'm going to show the audience something separate here. And so we generated the project, and I'll go over a couple things that it put into the project. So we showed the demo native module here. And again, this is just very similar to like the demo web and what it's setting up. Inside your demo web I'm calling it demo web. The name of my application is demo. Inside your web directory, you're going to get some additional things put in here. So we'll start with components. Right away, we have a layouts SwiftUI and a core component SwiftUI. And we make this look as close as we can to the original. This looks like the same embed templates function, but it's not. This embed template function is specific to us so that we can actually key off of the given format here in order to render the proper templates. But just like your regular layouts, you're going to have app and root, and that all works exactly the same. Inside your root template, the CSRF token is injected. And I think that this is just going to render out like, actually, I should probably check. I forget whether we changed that, but at some point there is still something that kind of looks, maybe the live reload injection. That still looks like a web div. But it doesn't matter because the client ignores it. This style tag right here, means just a verified route to, we'll go over that in a minute, your style sheet.
Okay.
And then your app, works the same way, right? So, it depends upon where you want to put stuff. Something to take note of though, is that the way that navigation works on SwiftUI and the way that we have to be able to manage the state of the navigation and manage kind of like especially the back button stuff, is that navigation has to be declared in the root template. And then when the client pulls down the dead render, we pull out the navigation, basically everything that's just outside of the LiveView div. And this gets wrapped outside of the LiveView. It's kind of a weird concept. And for a while, it has been limiting. Like in 0.3, there's no way for you to actually swap out the navigation stack, because the way that I had originally written it was I was tossing out the dead render. Like I would go through the dead render and pull some things out, the connection information, and Carson pulls out like the navigation stuff.
Mm-hmm.
But other than that, we weren't rendering it. And for 0.4, we're going to start rendering it. This actually may come out as a bug fix in 0.3.1. What we found was that for certain like LiveView navigations, like if you're switching between live sessions, LiveView does a disconnect. And what we were seeing in our state was that you'd briefly see like the disconnect view, and then all the latency of pulling in the dead render and then setting up the new connection and then pulling in that connection and rendering that was like, I have a video of it on my presentation for ElixirConf, but for an application we had that's in production, it's like a second and a half, which is terrible. And so there's a couple things that we can do better there, which is we can actually add latency before the navigation transition animation happens. And it's like anything under a certain number of milliseconds, you don't notice. And so we can kick off the request to the server and then like pause the animation for a certain number of milliseconds. And this makes everything overall just feel faster, right? Because you don't see the animation happening and then the post latency on top of that. In addition to it, when we are navigating, we already have this fixed on main, but when we navigate, we are no longer going to be allowing the state management to take over. So if during a navigation event, there's a disconnect, we shouldn't be rendering the disconnect view. In other words, like the disconnect view is meant for if the WebSocket dies and you're just like sitting in the application, or like if the server gets like they're redeploying a new version of the server, right? You like the disconnect view will attempt to automatically reconnect, but it'll also show you like a graceful fallback screen.
Gotcha. We have a quick question if you want to answer it. Is my understanding correct? The server sends all the code to the client, i.e. mobile, and Swift converts it in the client to what the user sees?
Just the markup, and we compose a new view tree. And so the idea of having like this navigation stack, for example, we parse this as a regular like composable document, and then we walk it. And we will like walk to this part of it, and we will say, okay, the tag name here is navigation stack. And then our dictionary, our registry is just a dictionary. And a dictionary is a map. Like this is like just different term types for Swift. We look up the string representation as the key here for navigation stack, and the key value of that is going to be the navigation stack view struct in Swift UI. And then we instantiate that and we inject the children. And so it's kind of like we do a depth first walking, and we kind of reconstruct the tree as we're going up. The styles get applied at the build time as well. So this style sheet here will get, just like on the web, we will pull it down asynchronously, and then we will parse it, and we instantiate all the modifiers ahead of time. When the client's booting up, and now they're ready, they're in memory, and they're there. And then the style sheet is just a key value pairings as well. So when you have a class name, it will go and look up the class name that's declared. Like if we had something like this, I mean, this is not a great one, but we'll do like class equals padding. And if we declared our own in the style sheet, if we declared our own padding class, we can then define all the rules just like we would with a CSS. And so we can group rules together, and then at the build time of this given Swift UI view, it will parse out, string separated for class names. It'll parse those out, look them up, and then just apply them to the for the view itself. So like this would be in Swift UI. This would be like this here, and then you would have something like that. And so this is
Okay.
effectively what it starts to apply at runtime. And this was something that was really, really slow. That took us a while to get to, because we had this, we had an attribute like this, and then we had modif like this. And I think they were even like, I forget how we were separating them, but we would parse that attribute value out at runtime on every single element. And then we would go and instantiate the modifier at runtime. And so this was happening, like it was like just a horrible performance overhead. And so moving over to style sheets was a way for us to preemptively instantiate and get everything loaded into memory. So now it's just like a hash table lookup on the dictionary, and we can apply it. It's like effectively as fast as writing it in like SwiftUI code on the like in the in SwiftUI itself. We did a performance. So React Native, I guess they have a new version of it coming out called like React Native Next or something like that. And they did some benchmarks where they compared the prior version of React Native to new version of React Native. And, benchmarks are always just like stress tests. So they would show like, here's how long it takes to render like 5,000 image tags or just like group tags. And so we did our same version for LiveView Native. And I'm sorry to say LiveView Native is not as fast as React Native. And that's because SwiftUI is not as fast as React Native. For doing like those crazy renderings, you're never going to render out 1,000 image views, because in mobile world, you end up virtualizing things. You don't have enough screen space. You end up virtualizing lists so that only what is like pending to come on screen ends up getting rendered. And as soon as it's off screen, it gets taken out of memory. And so because we are nearly as fast as SwiftUI continues to evolve and its performance improves, so should ours. We do have some work to do on a couple places for rendering, but overall, like these will come out in just patch releases. They're not going to be public API changing stuff. So as we develop the client, performance is top of mind. One thing that takes you immediately out of thinking something is a native application is latency. Despite the fact it is actually rendering native views in the SwiftUI view tree, if there's latency I tap something, and if it takes us a moment or two to render, that mentally takes you out of it. Yeah. And so we got to make sure that we are as performant as possible at all times. So anyway, back to this here. So just like a web application, we follow the same conventions as much as possible. We want LiveView Native to feel like an extension of LiveView itself, as if it was naturally part of it. And so there's going to be a lot of things that feel very familiar. So right away, same layout structure, same functions that we're calling here. The core components, what we ended up doing was we ended up just copying the core components HTML ones, and then we just wrote SwiftUI versions of these. So like, whereas I said before, there's not going to be any unified UI framework, because the markup itself is particular to the UI like target here, whether it's SwiftUI or Jetpack or WinUI 3, where we can actually unify the APIs around function components and eventually live components. And so in the case of, let's go down to modal. Like the API here, as far as calling the modal, is identical to the modal function in the core components file. So this is where we start to see some acceleration on the implementation side that we can leverage. And so finally, you have this styles directory here. And instead of doing our version of styling sheets up in the assets directory, I kept everything in Elixir. And there's some reasons for that. But the way this works is that you have a sheet sigil and we have a DSL. So if I want to do that, like that padding function here, I can do this. And then I can also like foreground style green. And this is where it starts to actually compose out. What this ends up doing is that this sheet sigil will get parsed. And why is this file in here? Style sheet, maybe because I don't have it compiled. And what this will end up doing, or this might be just the language server again. What this will end up doing is this will all get parsed out. We have a full parsing system in LiveView Native style sheet. And then we also have parsing that's specific to each client. So these are SwiftUI modifiers. The way
I was
that
going
the
to say
modifiers.
you're writing Swift right now, right?
Yeah. So that's what our goal is here. It's not actual code. We do not send code over the wire. What ends up happening is that this ends up declaring a class function, and it'll be padding right here, and then inside here, this will effectively get off my screen. This will effectively get compiled down into something like this, and so we create just AST nodes. And here, this will be like this. And then here will be a nil green. So.
Oh, shoot. Hey, I'm sorry. 1 second. Someone's at my door.
Yeah. Oh, okay.
All right. Sorry, guys. I am back.
Yeah. So doing all this pre-parsing speeds up the eventual compilation client side. We don't have to do any type of string parsing. It's a structured format, and we can just get it into memory as soon as possible. We end up eventually outputting this in the style sheet, and it's just going to be like a map like this, where it says padding, and then effectively this gets copied down to here, right? And so we use the same technique that Tailwind uses. That class names have to be whole strings. We can't at runtime build up the class name. It has to be represented somewhere in your code. We scan your project or the SwiftUI relevant files for those class names, and then we iterate through each one, and we run it against this class function in the style sheet. And because of pattern matching, we can now get the relevant AST node for that given class, and this gets compiled into a much larger style sheet. And that's what gets sent over the wire to the client ultimately, and that gets applied. We do something similar for style.
That's awesome.
And so the style attribute so we support both class and style, whereas class will actually look up and compile out the group together styling rules that are declared in your style sheet. Because we don't have a styling framework yet, we always found ourselves doing kind of one-to-one things. And so let's say if you wanted to just prototype something, you could do this here. And hello world. And so what ends up happening here is that styles need to be separated by a semicolon. And so we will also pull out the separated style rules here, send them through our parser, and then in your style sheet, what you're going to end up seeing is going to seem a little bit wonky, but it'll be something like this. I mean, the key will be that, and then you'll end up with the AST representation of that I showed before. So this, and then dot, comma, this, and then nil green.
So you're passing the AST or the AST over the wire, and then
it's just
the Swift side. How are you?
So we're not passing binary. We just do an inspect, and we spit out a string representation of the map. I mean, it's just Elixir literal being spit to a file. And we can see this. I don't know if it pre-compiled it yet or not. Let's see. Static assets. It's not. It's all compact. I need to expand it. These are the ones that are pulling out of the core components file, the SwiftUI core components, because they're all set with styles. And then on the client, we have Elixir syntax parsers that will go through and then a map will get loaded into a dictionary on Swift and to whatever Kotlin uses.
Okay,
But
nice.
that's actually going away. I like the Elixir maps, but they're one more thing, right? Elixir is not the most well-supported syntax on other languages, whereas JSON is, and JSON parsing is like incredibly fast.
Yeah.
And so this will basically get changed over to a JSON representation instead of a Elixir map.
Okay,
And
gotcha.
so that's just one less step for clients. Like, it should improve the render times as well. Okay, so I mean, let's build something really quick, and then we'll actually show it off. So what I'm going to do here is, and close all the others. We're going to add a live route into my router, and we'll get rid of the page controller. So we'll just do live here, and we'll do home live, and I'll do a mix. I'll just create the file. So I think if you do like mix phx gen live, it creates like a.
Oh yeah, you could create all the resources with it.
Yeah, I don't need that.
You'd probably get more than what you want though.
Yeah. So.
And I forget all the flags to ignore what you don't want.
I know.
always have to look those up.
So do I. So we're just create home live here. Def module demo.
The fear of coding live. You have to show that you have a memory.
All right. So let's see how I do. Demo web. Live view. I think is it underscore or not? This is where it's going to get me.
Oh my gosh, you're quizzing me. I think it's underscore.
Yeah, it's underscore. Okay.
Yeah.
And then we'll just do def render assigns. I forget if we fixed this or not, but I think that there was one point where we have to define the assigns even if we're not using the HTML render, because LiveView, because I think of a behavior, it requires render 1 to be defined.
Okay.
I think that's still the case. I'd have to go check. But we'll just do, I'll just do like a div. Hello, HTML. Yeah, just so it's there. All right. So what we're going to do is we're going to actually add use demo native live view. Just like that. What's this complaining about here? Oh, okay. Yeah, it's undefined because we haven't generated it yet. So next we're going to do mix lvn.gen live, and we're going to pass it the format first. So in this case, we're doing a Swift UI format. And then I think we just do home live like this.
Can you generate multiple? Could you generate like a Jetpack or Android version at the same time?
I think I gotta go back and check. I'd done these generators a while ago, and I think I did it. If you leave the format off, I think it will go through all the available formats and create one per.
Okay.
Or may complain. I forget, but yeah, those conveniences will be coming.
Nice. Okay.
So I just had a goof because I should have just done home, and it did home live. So let me fix this real quick. All right. So if I had generated the files properly, here's what you end up with. Oh, this one too.
We won't tell anyone.
I know. See, we talked about this earlier. Memory.
Dude, hey, I don't throw stones because I'm the same way.
It gets me. Okay. So this is a render component now. All of the state management and all of like the setting things up, if we were to do def mount, and then inside here, okay, assign socket, foobar, right? This is all still happening in here. In your live view, if you were to do a handle event, we'll just call it, I don't know, button press, and then, oh man, this is where thankfully the language server is working right now. Okay,
there
we'll call it.
Dude, it always stops working too when you're live, if you've ever noticed.
All right, and so in this case, actually we'll do something like more rudimentary. Let's do a counter. Do one there, and then we'll do let's see here, counter equals map.get. I guess we can just do assign socket dot assigns dot
Yeah,
counter.
just increment it right there.
Yeah, I'll just do. So now, oh, this is where it gets me. It's no reply off of this, right?
It's no reply. Yeah.
Yeah.
With is it an underscore? No,
I think it's just no underscore.
Okay.
So socket counter.
Oh yeah, that looks right. See, once you wrote more of the response, the tuple, then it clicks in my brain.
Yeah, and so anyway, okay, so we can do this here, but what you're going to do is that you can either write the render function inside the render component for SwiftUI, or you can use the generated template as well. Either works, but if you define the render, just like a LiveView, if you define the render function in here, it will not generate. It will not attempt to use the template. So the render function overrides. In addition to that, render 1 is discouraged from being used because what ends up happening under the hood here is that when a client connects, we pass in this other map called the interface object, and it's going to include a bunch of information. So we can do version here, and this is also a main. I didn't get it in for 0.3, but the version string comes in as just a string. I parse the version string per client, so that you can actually do range checks. And so in native land, we don't have any control over whether the new version of iOS 18 is going to break, iOS 17 apps. And so we need a way to conditionally render out different templates that target different OS versions.
Well, if you're building a native app, I feel like you have to add conditionals all over the place.
Yeah,
for that,
you do.
Right?
Yeah, you do a lot of that. You end up doing, I think that they're compiler statements. So they get basically the compiler, they'll get compiled out. So they're not there at runtime. But this comes in, this render 2 function is the one that you end up wanting to use. And instead of sigil H, you're going to use sigil LVN. And so we can do text, hello.
And then this is all SwiftUI, right?
Yeah. So this text element here is a SwiftUI text element. Cool. So if you were to go look up what's this complaining about? I bet you queries variable name assigns to exist to be set to a map. Oh, it's not. Sorry. There we go. If you were to go, what we wanted to have, what we didn't want to do was having to reproduce all of SwiftUI's documentation, right? That's just a nightmare. And all of the documentation for all of the all the libraries.
When I was glancing through your docs, I was like, dude, I wonder if they mirrored all this to a DSL, because that would be a nightmare.
CodeGen does wonders. But even then, the documentation that we have on Hex is pretty limited, right? So if we were to go onto Hex docs, if I look up the SwiftUI documentation,
I think you have enough though to put it together, right? To figure it out.
Well, here, these are all the supported views. This will get reorganized at some point because I don't like how it's all in one place. But let's say lazy H grid, for example, right? We have a generated version of it and shows you how to use it in LiveView Native. But then if you want to know more, you can go to the Apple documentation. And if it's in the Apple documentation, we should be able to represent that in LiveView Native. Okay. There are certain areas that we can't, and it's escaping me at the moment exactly what we can't necessarily represent or why we can't represent it. But in most, it's 99% of the stuff we can actually represent in our markup. Anyway, okay, so back to this. Sorry, the cold is starting to hit me now. All right, so what we have here is a LiveView Native server. It's saying hello, LiveView Native, and this is where it could completely blow up in my face.
It's gonna be perfect.
I know. So what I'm not going to use is Xcode. So Xcode is going to take 5 minutes to compile, and that's not fun. We have this other application we built called LVN Go, and so did I download a new one? I might have. Let me see here. Where's LVN Go? Okay. So LVN Go is a LiveView Native client that allows you to now point the client at any URL. So if I do, I don't think I need, because I'm on the same machine, I didn't change the ports here. Oh, sorry, the IP address. I think this is fine because I'm still localhost. So let's try here. Localhost 4000. All right, so there it is. Hello, LiveView Native, right there. We rendered. So this allows you to not have to deal with the nightmare of Xcode. So let's see here. If I were to update this and I say hello.
What is that behind the? This is an in-house tool. I'm assuming you developed to avoid...
No, sorry, it's on the App Store.
Oh, it is.
So,
okay.
Yeah, if you go to the App Store and LVN Go, it's right there. You can download it.
All right,
it's
nice.
available for Mac, iPhone, and iPads. We have built specifically for those devices, and probably in the next, couple of weeks, we'll get builds out for Apple Watch, Apple TV, and Apple Vision Pro.
I think that it's funny that you guys had to build an entire tool because Xcode is so slow.
Well, this makes development way easier.
I'm sure.
Because now, you have something that just works.
Yeah.
So on top of that, I don't know what version of LVN Go I have here. I may have had a pre-release version.
How does it work if, let's say you also had Android?
Oh, okay. So this is So this is just the SwiftUI one, and again, this is connecting, and then when it connects, it will connect using that _format query param SwiftUI, and so it knows to delegate to the proper render component for that given format. If we had Jetpack in here, then we would have Jetpack render components, and the Jetpack client is connecting with _format equals Jetpack, and so
gotcha. It
knows to delegate to the proper render components.
Okay, nice. That's awesome. Very cool.
So let's test out some style sheet stuff. So let's do style first here, and we're gonna do foreground style. Change it to green. Save this, and now on the right hand side automatically updates.
I love the reload right there. That's
yeah.
Cool.
I love to take credit for it, but this is all just live reload. Our version of live reload is not doing anything different than the live reload plug that comes with Phoenix. The only thing is
you have to re-render the X project.
Yeah,
stuff,
but we treat it. We so if we were to do, let's look at this. So if I do format SwiftUI, okay. So this is the text we get from the dead render, right? Mm-hmm. And inside here somewhere. Right here is the iframe, the live reload iframe. We just look for that and we pluck it out. And if it exists, now we have the URL we connect to for the socket, and we just listen for the live reload event. And when we get it, just like on web client, we force a reconnect of the application.
That's awesome. Very cool.
And so it just works.
Yeah, awesome.
Okay, so now we have styles here. If we wanted to do, let's do an HStack. And HStack. Oops. So nothing's going to change there, but what I can do is I can put an image next to it. So image and call system name equals star, I guess as well do. So we get a little star right next to it, right? And so these are, again, all things. If I were to go look up the image view for SwiftUI, it would show me I can pass in the system name named argument to it. And system name is there's entire it's called SF icons, I think, SF symbols. All of these things you can use in SwiftUI. And these are all just different vector icons that can be brought in. Or you can reference an image that is part of the application. So in Xcode, you have what's called the assets catalog, and it's how you can bundle in images, videos, any asset really. But you give it a name. And so I think it's just name at that point. It has to look up by name. And so it referenced the locally bundled asset.
Whatever PNG or whatever you have there.
If you want to do async image, you can pass in the URL, and then it'll it'll do all that for you. So it'll go get the async image. But the thing with async image is that it's async image is a view, and it's not an image view. What it is that it's a view that kicks off an asynchronous event of going to fetch that image, and it will render out different states or different phases of receiving that image in SwiftUI. So there's like a pending state, so you can show like a spinner or a skeleton UI, and then you have the finished state. You can now get the image, and then within SwiftUI, you have to actually do something like this. It's like, it's like async image, URL, whatever that is, and then inside here, you get, I think it's like a phase there, and then you're like if phase dot complete inside here, and now you render out like an image here, and you do like phase dot image, I think, and then off of this is what you end up wanting to style, right? So if you want to actually style that, like if it's the image is too large, right, and you need to shrink it down to a proper size, you have to do it like that in SwiftUI. Well, we have to do the exact same thing in LiveView Native, but that's a bit of a pain in the butt. So if we look at the core components file here, core components SwiftUI, and we go to def image. So we have an image one that does it for it automatically, and we can accomplish the different image states through the slots in the function component, right? So we can do async. We can just do image URL equals. I'm going to need a URL. Let's do Elixir Lang. This is probably going to be an SVG. Oh, okay. All right. So let's get this full URL here. Let's see. All right. Let's see how this works. We'll go. Okay. So we'll do this. And then just make this wider for a minute. Just bump down a little bit. I'm hitting my limit on my size.
People are going to be so pissed in the comments now.
Okay. So let's see what it did in the client. So there you go. There's the image. It downloaded it properly. But what I can't do is pass in, I can't pass in styles directly on here, right? So instead, what you have to do is, I think it's success style equals frame. Let's do width 10, height 10. I think this is it. I may have to look at the code. Connection failed. Oh, because the server crashed. Missing opening tag for image. What did I do wrong? Am I closing this properly?
Is it? Should it be :success or .success?
Maybe .success. Let me just check out image success.
Okay, cool. Oh, and then so failure, you could have a default image that just loads that you have locally.
Yeah, this didn't work. Hold on, why didn't it work? Success class equals. Am I not spelling success properly? Go away. Why is that thing showing up over my cursor? Style equals success.
Someone said you need to close .image.
I need to close. Do I not have it closed? I have .image closed.
You don't have
Sorry. Yes, you're correct. Thank you. Okay. All right. So now
thank you, Alexander. You are a hero.
Resizable. Okay, there you go. Now it's tiny, right? And so that's how you end up styling the images that are returned from an async image. So this is like an example of how, like, while we're leaning into as much as possible to make it as familiar for LiveView developers, like we are not divorcing ourselves from what SwiftUI applications are built like. Mm-hmm. And so you need to understand you need to go look at the documentation. You need to understand those things. And we provide a lot of, through the function components, we provide some easy points here, but we can do animations, we can do drag and drop stuff, we can do gestures, and all these things are just accessible through there, but you need to do it in the SwiftUI way that it's expecting things ultimately. Okay, so let's back this out a moment, and we'll just get rid of the image, and we'll move over to using classes, and I'll show you how that works. So this is gonna now go back to Elixir Mentor over here, and I'll do we'll call it heading. and there's nothing there yet. So what we're going to do now is we're going to go down to our styles directory, open up the app Swift UI here, and we'll create a new one, heading, and I'll do foreground style dot red. Oh, great. Oh, I think I think that this is actually a bug I have to fix here, where sometimes
doesn't reload the style sheet.
No, it was actually, sorry. I pointed this out when I was installing it. I forgot to fix it. The live reloader pattern gets generated.
Oh, that's right. The dot asterisk.
Yeah. I got to change this. So this has to go here like that. And this should reconnect in theory. It should there we go. Okay. Is that red? I can't tell. No, it's not red.
That doesn't look red. Unless
All right,
I'm colorblind.
Yeah, I think that this is actually there we go. Okay. So it gets into like a weird build state sometimes. I use the is it like the mix recompile callback on the module? I feel like I still have a slight build bug where not off of easy stuff like this. So if I were to change like I don't know another one to do with the top of my head. I guess I go with padding in there. We're not really going to see it, but you can see that force the live reload at the very least, because now it's in a good build state. But I think perhaps because I had the wrong live reload pattern in there, it got into a funky build state.
Oh, that was in your config file, wasn't it?
It was, but I used that pattern when you compile the module. It pulls that pattern out, so when it attempts to recompile, it's looking for files that match the pattern.
Gotcha.
And I think perhaps because it was there's all these like weird things you can get into when you start doing a lot of like the macro and like compilation side of Elixir, where it's easy to get into a bad build state. And anyway, we already have that. Again, that's fixed on main. It's going to get released as a patch release. But if that weren't the case, it would have been fine. So, I mean, this is, I don't want to get into too complex examples because we're very going to quickly find my limit on LiveView Native knowledge. Sorry, on Swift UI knowledge. But we have other things we can point at too. So let's back out for a minute.
And this is cool though. I appreciate the demo. I'm always like hesitant with demos, especially because this is more conversation based. But
yeah,
I think we needed it because it's pretty cool.
So Justin Tormey built an application called Lax, which is a Slack clone built in LiveView, and we built a LiveView Native client for it. So you can go to you can point it directly at the production server. I see if it's asleep. I think it may be no one's using it, so the fly instance is probably not woken up. But we'll just disconnect and try that again, just so you can see that it's fast, like the next time, relatively fast. Why is that taking so long? That's interesting. It shouldn't be taking. All right.
Maybe it's OBS and us streaming.
I don't know. Something's not right there. I wonder if it's bombing out on me. This should not be slow. I wonder what's going on there. I mean, it could be the stream or something's odd there. Anyway, we could go and like launch it on your phone. LVM Go is available for your phone as well. And the Lax application, I think, is you have to search for like Lax Chat. It's right here. So this is a LiveView Native application that's in the App Store, and it has all the aspects of like what you want out of a native app. Nice. It has authentication. It has state management. It's a pretty common, I say, a easy thing for you to kind of wrap your mind around in terms of like understanding why this was one of the first applications to do, because it's like you get all the benefits of Phoenix, so presence, the fast rendering from LiveView, all that stuff. And on top of that, Justin has it open source. So if you wanted to go and look at it, you can go and look at all the source code.
That's awesome.
Last thing I'm going to show off with LVN Go is actually, we'll see if this slowness persists, but we have a cookbook that we released. And the cookbook is a bunch of like recipes on UI components and then navigation types. So if you point at, or even if your browser, like if you go in your browser to cookbook liveviewnative.dev, and this is on a free fly instance, so this definitely has to be woken up. But what you can do on your phone, if you go to this URL on your phone, you can click this open in LVN Go button. And this actually uses an app clip. App clips are like partial native application downloads. And it will go and install LVN Go for you automatically. And it will boot up the cookbook. So in this case, though, because I'm not on mobile, the app clip is not supported. But I'll go directly here in LVN Go. Dev, launch this. And so that booted much faster this time. I don't know what's going on with the Lax application. I should mention that to Justin. But this is all native UI stuff. So we can show off like card rows. We can show off charts here. And
this is awesome.
Show charts being generated. See if the maps one. Yep, so maps works. Can move around the map as we would. Zoom in. On the mobile application, you can actually drop down into street level as well. Let's see here. Video player. Oh, that crashed it. Why did it crash it?
Because you're live. That's why.
I know. That's why. So let's go back into LVN Go. Launch it back up. Message threads, all these different patterns and such, right? And so if you have a way, like, how do I do that in LiveView Native? Mm-hmm. We may have it represented here, and we're going to continue to add more to it. So that's awesome. Is also available as an open source repo on the LiveView Native organization for anyone to check out and start to play with. So, I mean, that's kind of like the high level of LiveView Native and getting you up and going. And I mean, I'm ready for people to start using this. I've been ready for a while now, and I'm really excited to see like kind of the future that happens here, because I look at, I know that people that are developing their own open source project, they kind of consider it to be like the best thing in the world.
Yeah.
But from my perspective, as a business owner in the software consulting world of Elixir, we see more and more reasons for people to opt out of Elixir from time to time. Like in the sense that, like in a tech stack, Elixir sometimes ends up being the odd man out, right? Yeah. You have like React on the front end, you have React Native, you have like different like parts of the stack, and then at some point, someone's going to say, oh, we only have like the small team maintaining the Phoenix app. Like, why don't we just like go fully isomorphic? So Elixir needs to be able to answer these questions where it says, hey, now we have a native application development environment. You can stay in Phoenix.
I think this is huge, especially for the Elixir stack for sure. Because like I have a consultancy as well, and you want the least amount of code bases that you can have per project,
Yep. No, absolutely. We did some tests where while a framework such as React Native has a unified UI, like Flutter the same, we took a non-trivial application and we actually shopped it out to a bunch of other consultancies. We paid them for the estimation. We didn't tell them what we were doing, but we asked them to effectively give us these shops were roughly the same size and experience and like age as DockYard, and ones that we trusted. And so we just asked them to estimate it out. And on average, like the LiveView Native application took 40% less time to build. And that all came down to like, we didn't have to replicate all the state management and all the event handling over and over again. When you wanted to add a new client, you just added a new template. And, there's time to build up the views there. But one thing that we have been starting to experiment with is, well, we haven't released yet. We have a transpiler that will take SwiftUI, like strip SwiftUI code, and transpile it out to LiveView Native markup. It'll take all the modifiers and properly set them as style attributes. And so that's one way to speed up the development. The thing that I think would be really nice, if possible, is like design tools like Figma are starting to push forward this idea of ML generated markup from the designs, and they have an experimental SwiftUI one, and we just haven't really tested it too much. But it would be like insane if we could just have our design team mock something up, spit it out in SwiftUI, we transpile to the LiveView Native, we drop it in. Yeah, and I mean that will significantly speed up development.
That would be really nice. I love that. Yeah, I'm excited to get my hands on this. I have to carve out some time now and play around with it.
Cool. So I don't know if anyone else is on, wants to ask any questions,
Yeah.
but I think
If
I'm
you
done with
guys
the demo section.
if you guys have any questions, now's the time. Well, we got Brian, and then if there aren't any, we can close this up. But it's been an awesome chat. I really appreciate you coming on. And LiveView Native looks awesome. I feel like
I hope I hope it's starting to show like why we held it back. Like we want it to be good and solid.
Well, you don't ever want to release anything that doesn't work well, because then
Yeah.
you lose your adoption out. You lose the hype
it's
and
also
adoption.
like software development, you go.
Yeah, exactly.
Making sure that it works.
Let's see. I think we might have had some questions at the beginning. Some unrelated LiveView questions, if you want those.
Sure, I'll answer what I can.
It's just, as you like boats, Aldelfo, did you read Bruce and Maggie Tate's book on the Great Loop?
Great loop trip. No, I haven't read it, but I have spoken to them about it quite a bit. And so they had a powerboat, and doing the Great Loop is this connection amongst like rivers and I imagine some man-made.
It's essentially like the Mississippi through the Great Lakes channels, and then down the east coast of the Atlantic, right?
Right. And so you have to go through a lot of locks, and it takes time, but it seems like it's a pretty enjoyable thing. I don't think it's possible at all to do that in a sailboat, because
I don't think you're sailing through channels.
No.
Well, you'd be motoring a lot.
I mean, the problem on my boat, I have an electric engine, and so my motor doesn't last very long.
So what kind of boat do you have? Is it racing?
Yeah, it's a racing boat. It's called a CCF 24, and it's a 24-foot like high performance racing boat. What I've been, in addition to all the other stuff, we have an R&D project within DockYard that we're using to dog food some stuff on NX, but we are building out what's called a computational fluid dynamics simulator. It allows you to actually simulate the flow of a fluid over a body and anticipate like the change in direction and velocity. Well, the change in velocity of that flow. And these exist out in the market, but they are slow. So
are you getting into, is this like embedded software?
No, it wouldn't be embedded. I mean, this would be more of like, these run on supercomputers, like the opposite of embedded.
Oh, gotcha. Okay.
Because they take like a single frame can sometimes take hours to days to weeks to months to render, depending upon the complexity of the frame itself, like the mesh complexity and the actual complexity of the lattices that you're trying to simulate against. Anyway, all this to say, we tried out some stuff where we're doing more of these calculations with a newer method called Lattice Boltzmann, as opposed to an older method called Navier-Stokes. Navier-Stokes is more trusted, but there's been some recent academic research that can actually close that gap significantly. And also, when we're doing it for sailboats, we're typically operating at like low wind speeds. And a lot of the deviations where Lattice Boltzmann starts to break down is like past Mach 1. So for our use case, it's not like even remotely close. And we can get very highly validated results with doing a lot less work. And we can also do them with floating points. And so we can push the work to GPUs. And this is incentivizing us to look into distributing the work with NX. So the idea then is like a single rendering. If you think about like a mesh, like a 3D model, you then have effectively like a mask over it of like small little lattice cells. Each of these lattice cells can express pressure on it in multiple dimensions, and it can also get pressure information from its immediate neighbor. What if we could represent each of these lattice cells as like an Elixir process, and then effectively like go as wide as we want, with clustering? Again, network latency could be an issue. We're going to figure it out, but we're kind of going down this road of attempting this. Our immediate results, we're actually getting near to the point of publishing a paper on our two-dimensional solver, and we're seeing orders of magnitude performance increase over like common solutions right now. That's and so awesome. It's looking really, really nice. Anyway, all this to say, it will eventually feed into what I am hoping is going to be the problem in sailing, especially amongst racers, is that it's like, it's unfair in a lot of different ways, because you have boats of different characteristics that are racing against one another, and you have a handicap system that is not sophisticated enough to really account for those differences. But you have a bunch of like old salty guys are like, this is what it's always been. And meanwhile, the technology keeps improving. And I've always felt like if we can actually get to an accurate representation of what the handicap, should be for given wind speed and like boat type, it will improve participation. Because I know a lot of people that have just left the sport because they love their boat, but their boat sucks when it comes to like handicap racing.
Yeah.
It's a big problem that exists in the sport. And in a lot of ways, like the boat builders have been exploiting it. Like they get in with the handicap systems and they get sweetheart ratings and like all this stuff.
I mean, of course. I mean,
it's their business.
Right?
Yeah. And so we're trying, and these rating systems are also closed systems. You can't like figure out what's wrong with it. All you can do is wait. You can like appeal and they say yes or no. It's pretty frustrating. So we're going to do everything open. In other words, we're going to keep it as open as possible. And this is what, I mean, amongst all the other things I'm involved with, this is the thing that I actually love the most is, doing something to actually make an impact potentially on the sport of sailboat racing.
I love that. That's awesome. I miss sailing. It's hard to do in Utah. I mean, I guess there's big enough like reservoirs, but
I mean, it's going to be dinghy racing there primarily. I guess a lot of small boat stuff. I've never sailed out there.
Yeah.
But well, thank you for having me on.
Yeah, thank you so much. This was a lot of fun. We'll have to do it again for sure.
Definitely.
All right, guys.
Bye, everybody.
See you guys. Testing.